Welcome to the first Sunday session. The first talk will be by Graham Dumpleton, and he's the author of Mod Wishy, a popular module for hosting Python web applications with the Apache HTTPD web server. He is currently a developer advocate for OpenShift at Red Hat. Can we please give a round of applause to Graham?
Thank you everyone for coming. This is the second day in a row I've been stuck right behind the keynote, and I know it's probably a big letdown because Russell did an amazing job this morning as usual with his keynotes. He's always a lot of fun to watch what he has to say. So let's get going. Decorators. Everyone here knows what a decorator in Python is, has seen one, used one, I assume. So would you agree that they're useful? Yes. Yes. Are they easy to implement? Yes. A mix. So for the people who said yes, are you absolutely sure? Here is your typical decorator. We are using a function closure, so nested function, whatever you call it, in there, and we're going to create that, and we're essentially going to use this special @ symbol, this syntax, to apply that decorator to that function. So it looks simple, doesn't it? Okay? But this breaks various things. It breaks introspection. So name and doc attributes are not preserved, and various other things. But you might say, but that's what functools wrapt is about. That's supposed to solve all of these problems. Right? All we're going to do is in our closure inside there, we're going to put that functools wrapt in there. Magic, it's all going to work. No, it doesn't. It still has issues with introspection. So if you try and grab the signature of that function and your closure function is using *arg, ** keyword args, like rather than named arguments, it doesn't bring back the right signature. There's also problems with using that decorator in that form on another decorated function where that other decorated function is using a descriptor. So like a class method, for example. Can have problems with that. So functools wrapt does not solve all the problems. Now, there's various other problems as well. I'm not going to go into this talk. I've done a talk like this before, and I just put too much information and killed a lot of people's brain cells. So there is, if you go to my blog, go to the right-hand side, there's a quick link, and you can find this decorators and monkey patching section, and it has about a dozen blog posts on the topic of decorators, what's wrong with them, how to implement them correctly, and start getting into a bit on monkey patching as well, which is I'm going to talk a little bit about in this talk. So please try not to implement decorators yourself. That is my advice. But what is the solution? The solution is this package I wrote called wrapt. Okay? So trust me. But let's see how this works. So very similar to before. In this case, I'm actually supplying a decorator within the wrapt library itself, which is a bit of a chicken and egg problem because that decorator is actually implemented in wrapt. So I'm using then that to actually help you create one. And you'll see that it's a little bit different. We're passing it, your wrapper function takes wrapt, which is the original wrapt function, an instance, and args and keyword args. I can use that to then call the original one. Now, the purpose of that instance is one of the things that wrapt decorators can do, which you can't easily do with a normal decorator thing, is that you can create what's called a universal decorator. When you use implement a decorator using those function closure, it's not really as simple to determine whether that decorator was applied to a normal function or an instance method or a class method, right? Or a class. If you needed a decorator which had to work in all those different situations, it's almost basically impossible. The thing that Django does, for example, they have a decorator which they need to apply in instance methods or functions, and they end up having two versions of it. Okay, so it's not that hard, or not that simple. So one of the things that wrapt has that by passing in this extra instance argument, it gives you a hint as to what actually you're being, the decorator was originally applied to at the point that your wrapper function is being called. So you can actually determine whether it was applied to a class or a function or a static method or a class method and instance method. And this is where you can actually implement this universal decorator. It can actually determine the context it was in use, and you might be able to use that for doing special magic or generating an error if someone used it in the wrong context. Now, using that ability of universal decorators, one of the features that wrapt provides if you're doing multi-threading is a Synchronise class, a Synchronise decorator. Now, people have tried this before, but it runs into those same sort of problems of when you're applying it to a function or a method of class. Most of those implementations, what they do is that they're putting a lock just on that one function. But if you're locking a method of a class, you want to lock the whole instance. And if you know anything about Java, it has a synchronized keyword. And it works in various ways. If it's applied to just a static function, and it just locks that one static function. If you apply it to an instance method, it will lock the whole instance and so on. So one of the bonus features in wrapt is this synchronized decorator, and it works basically very, very similar to what it does in Java. So if you put it on a normal function, it locks that one function. If you put on a method of a class, the lock will be bound to that instance of the class. If you put it on a class method, you're locking the class type. And if you put it on a static method, it locks that function. So that's a bonus. Now, other interesting thing is it's a decorator, but I've actually also made that decorator a context manager. So it's actually serving two roles. So if it's not convenient to apply that synchronized decorator to the function as a whole, you can actually still then use it as a context manager inside of that function to be more fine-grained how you do locking. So that's a bit of a bonus feature. Now, as I said, very useful library, I think. And I said you should use it, but should you trust me? I keep getting pestered to get wrapped inside of the standard library, okay? And this is from core developers in Python. So if you thought, should you use it, that might give you a bit more confidence. So this is not going to make it into Python 2.6, it's way too late. But, well, it is next month, the cutoff. Come on, you want me to get it in 1 month? Because there's actually going to be a lot of work to put stuff in the core, into the standard library. But I keep getting pestered about it. I had another discussion about it last night with Nick Coglan. And so maybe we'll try and aim for Python 2.7, but that's like 18 months away. But so it'll be a time. Anyway, I wrote this wrapt library, and great, it's got this decorator implementation, and people know it for that. But that's not actually what I wrote wrapt for. What wrapt was originally written for was for monkey patching. And it's weird, these sort of concepts of what you need for both are very similar. So very similar. And for those who've been using Python long enough, that decorator syntax, that at symbol, what you should put there in front of the decorator name when you apply it, didn't always exist. It was only introduced in Python 2.4. You could still do decorators before that, you just didn't have that nice syntactical feature. The way you did it was you essentially, down the bottom there, where you had your function, and then you actually replace the function with your decorator passing in that function. And that sort of model is sort of like what you're more familiar with when you're doing monkey patching, and that's why decorators have that parallel. You're actually changing the behavior of some existing code by putting a wrapper around something. So wrap was originally for doing monkey patching. Now, the difference, I guess, when you look at this is that, especially with that at syntax, when you're doing decorators, you are setting up that decorator and it's evaluated at the point your code is being defined and parsed in, okay? Whereas decorators, it's being done after the fact. So you're not using the same syntax because in many instances your code may have already been imported and you're actually going to go back and try and retrospectively monkey patch it. And you're going to do that by straight assignment. Now, why would you want a monkey patch? You may want a monkey patch to fix bugs in third-party packages that you're using. You may have identified a bug, you may have reported it upstream and they have fixed it, but it may be some time before they actually release a new version of that package. And you need to do something to still allow you to use that package to make it work. So that's one reason. You might use monkey patching if you're doing unit testing. So people here maybe will be familiar with the mock library, which is a testing library, and there's a variant of that now in Python 3.something as well. And the idea there is that you're monkey patching in the code to actually replace existing code to make it return mock values or have stub functions so that, you know, when you're doing your unit testing, you're not actually making a call out to some remote web service. It's just going to say, great, I did that, and here's some dummy results. So that's another use for it. And another use, which is the original reason I wrote wrapt in the first place, was related to monkey patching code to add in special wrappers for dealing with instrumenting code for performance analysis. And that was where I originally came from. So monkey patching with wrapt, how would you use it? We have a module up there with our code in it. We want to monkey patch. We have a wrapper function which we're going to apply to that. And it's just a simple matter of importing wrapt. And we're going to get wrap function wrapper. We're going to give it the name of the, or we're going to give it the actual class that we want to monkey patch on, the name of the method, and here is our wrapper. And it's going to apply it. Okay, it's going to apply it for you. Now, very important, we're not going to do this. And you may have thought, well, yeah, can't we do this? Which is very similar to what I showed when we had the decorator example before. We just reassigned the original value and replaced it with a new one. We don't do this because it doesn't actually always work. There are certain corner cases where this causes problems. It's all bound up to how method binding works in Python. So when you actually call a method on an instance of a class, there's a bit of magic in there which actually creates what's called a bound method. So it's applying that instance pointer and joining it together with a function to be called so that you're applying that function to the correct instance. There's some weird cases around that. If you do a direct assignment through the class, the binding means you're actually binding it to none. And that causes various problems. So don't do that. We let wrapt do it for you because I do some funny fancy tricks with diving into dicks to actually make sure all it works correctly. Now, in that prior example, in order to do that monkey patching, we imported the code. We imported the other module first that we wanted to actually apply the patch to. And that's a bit inconvenient, so we can skip that. We can use a decorator inside of wrapt, which just says patch function wrapper. So what will happen is instead of the actual name of the class here, I've actually given it the name of the module, and then I've given it the name of the class and the method as a path. So what will happen now is that'll get parsed, and as it gets parsed, it'll see that, and wrapt will go and import that module for you behind the scenes and apply the wrapper. So we can make it a little bit simpler. Now, what about testing? Okay, so in all those cases, I'm applying a permanent patch. Okay, so that's the thing of decorators as well. You put it in place and it's always in there for the life of the process. Now, if we talk about testing, we want to apply a monkey patch, but only for the length of that test. We want to remove it afterwards because when we go and run a different test, we may not want that error in place and we're going to patch something else or apply a different patch to have it do something differently. So we need a way of taking it away. And again, this time I've got a different decorator we can use. This one's transient function wrapper. So this time I'm actually that's a declaration. It's not actually doing anything at that point. It's just setting up that decorator. And then I can actually use the name of that decorator in here. And what will happen is that when test method is called, it will go in and apply that patch for me, importing the module as necessary. And once the method exits, it'll remove that patch. So that is where we want to intercept something that's happening when you call a function. Now, what if we didn't want to apply a patch? So we want to apply a patch to a class, a method of a class, but only to that one instance we are dealing with. It may be the case if we were to apply the patch to the whole class in a test or in a real-life system. If we do it to everywhere, that might cause problems for the rest of the application. So we want to do it to one particular instance of the class. Now, what there is in wrapt is what's called a transparent object proxy. If you've ever used weak refs, there's an obscure class in the Python standard library called weak ref proxy, I think it's the name. The idea is you essentially take your proxy class, you've got your original, and you're going to create an instance of this such that this has got a reference to it internally. And every operation you do on the proxy then will essentially be then made on the original. So the idea is that you shouldn't really notice a difference. So in this case, what we can do is we want to override the lookup method on just my one instance of that class. So I'm actually going to derive from this special object proxy, and I'm going to just override that method. Create my storage proxy, give it the original one, and I can call that one, and I'll call my override one. But you see this one here, clear? That clear method would have existed on the original object I wrapped, but the object proxy will just magically pass that through, and you don't need to know about it. Now, beware though of ordering problems. The examples I showed before, one case I imported the module explicitly and then applied the patch. The other one was doing it when it saw my my patch decorator with the patch function wrapper thing, and essentially that caused that thing to be applied at that particular point in time. But what if someone's already imported that module previously, and I wasn't the first person to import that module? In Python, you can do this, from example import function. And what's going to happen is in module.py, it's going to hold a direct reference to function. And what that means is actually really two ways of getting to that function now. The original example module and also in my module. So when I go down here and do my patches one, if I were to import this, apply my patch, I've given it the name example in the function, it's only going to patch this one up here. It's not going to patch this one here. Which means that if some other bit of code you're expecting to everything go through your patch now, is not going to get your patch because it's got own internal reference to it. So order of imports and ensuring you get in first to apply monkey patches is a big problem. G-event and eventlet have this problem. If you're familiar with those, they are ways of adding concurrency into Python application using greenlets. And so what it's going to do is going to go in monkey patch this Python standard library and replace a lot of stuff related to things like multi-threading. So that when you create a thread, it's actually creating one of these things called a greenlet. The problem is that you're going to start up your Gunicorn server, which might have G-event enabled in it, and at some point along time, G-event will apply its monkey patches. But Gunicorn's already started and it imported all these modules from the Python standard library, and the patching is done too late. So one of the critical functions it patches is time.sleep, because rather than going actually really sleeping, it needs to say, I'm going to let another greenlet run. So it has to actually, instead of just going to the time module, it has to know, oh, that sleep function was also imported directly into all these other modules and has to go and patch them everywhere else too. So it's not patching one spot, patching many. So it causes a lot of problem. The other problem is that if you think about with, especially the G-event inside of Gunicorn, is that it needs to apply all these patches everywhere, but you may actually not use some of those modules that it's patching in your application. But it's still imported them all. And that's going to take up memory in your process. So you can get the situation where it's going to get all this extra code imported that you don't even need. So how can we solve this? Now, there was this PEP that was created, PEP 369, had a feature called post-import hooks. The idea with it was that you could have this, you might want to make modifications to a module when it's imported. And the idea was you could say that, you could make that specification. So you could put a definition of this decorator, which was when imported, module example. And that's not actually doing anything at that point. If later on the example module is imported, then this will fire off and then apply the patch. And you can apply that patch before anything gets it. So where we have from example import function, this would have got in first. Okay? Now, the problem, you've still got a problem here. What if example was already imported first? So the problem with it still is that you need to do that very, very first up in your application, right at the start. So you've got to change your application. So you want a way of triggering this monkey patches. Oh, the other thing is you've had to modify your application to do that. So you're modifying code. So the next thing is how do we modify the application, or be able to monkey patch code without actually modifying the application code in the first place? So imagine you want to use, what's an application? Some Python application. I can't even think of one right now. There are lots of them. So imagine, well, just take Unicorn, for instance. Maybe if you want to patch Unicorn because it's got a bug in it, right? You can't go and modify easily Unicorn's code without forking it and making your own modified version. You want to apply patches to Unicorn itself. You want a way of doing that. And this is where another package I wrote comes in. There's one called autowrapt. So we can pip install autowrapt. And what we're going to do this time is rather than have our own code, which is somehow imported by us making changes to the application code of Unicorn, for example, we're going to package up our monkey patch that we want to apply as a module in itself. So here I've got a setup.py, which is what you use to create your own package. And the key thing here is I'm using this feature here called entry points, which is part of the setup tools. And what that's going to do is I'm just defining a declaration here. It says that I've defined an entry point which is called wrapt whiskey ref debugging, and I've given it this dictionary up here. And I'm giving it, in this case, I want to patch a module called whiskey ref simple server. And I want this function to be called when that module is imported. Okay? So it may not be too obvious. I can then have my actual monkey patch code, and essentially this is that function that's going to be called when that module is imported. And it's just going to print out that we're going to patch this module. I'm going to wrap a function wrapper around this whiskey request handle, and I'm going to wrap this function around it, this thing called time function. So I mentioned Unicorn, and I totally forgot that my example was set up for this whiskey server in the Python standard called whiskey ref, in the whiskey ref module. So anyway, that's what we're doing. So the purpose of what I want to do this for is that I want to patch this existing whiskey server to put a wrapper around there so I can time every HTTP request that comes in and put something out. And I don't want to modify the original code. So I've packaged up this patch now in a module, and I'm going to install it. I've got my autowrapt module already installed, and this is where some magic happens. I'm just going to, I went backwards. That's better. I'm going to define an environment variable here, autowrapt bootstrap. I'm giving it a name of my entry point that I created. I'm going to export it. I'm just going to run Python with my app. So this is an app.py, which inside is using whiskey ref whiskey server to run my app. And that's the code I didn't want to modify. And look what happens. It works. I have not changed the original code there at all. Does it look evil? It is a bit. It's using a very naughty feature in Python. In Python, when you install a Python package, there's a magic file you can install called a .pth file. It was originally intended as a way of installing Python packages into a version subdirectory. And then the .pth file would act like a symbolic link, if you like, and in it would be the name. So you might have installed Unicorn, and it's installed as whatever version you're up to, 20. So Unicorn-20. But that won't be found when you import it. So then you have a unicorn.pth file, which inside has unicorn-20, which acts as a symbolic link. It's a way of telling Python, well, for this module, actually look in this directory. Somewhere along the lines, and apparently it was something to do with codecs for Unicode, I think, or some other. Someone had this brilliant idea of allowing executable code inside of that .pth file. If that .pth file starts with import space, it'll execute that line of code. It's a really nasty hack. I wish there was a better way of doing it. But this is what I'm using. I've installed the .pth file, and I'm not sure if I have the code for it. No, I don't. It will look for that environment variable, and if it sees that environment, it'll import autowrapt and fire off a bootstrap routine, which will then go and register. It'll look up all those entry points I've defined, and will that way later on, when those modules are imported, it will trigger all my hooks and do nasty stuff. Now, the reason I don't like .pth files, if you remember ModPython, please tell me no one here is using ModPython. ModPython, if you've used it in the past, it's a precursor to ModWhiskey. I managed to kill ModPython by writing ModWhiskey, which is a good thing. One of the problems it has was that ModPython embedded inside of Apache. Apache starts up as root. And the Python interpreter in ModPython was initialized inside of the Apache parent process as root. So if you could socially engineer your system admin to install your custom Python package you need into your system Python installation, and you put one of these nasty .pth files in, which had executable code in it, you could gain root. Very nasty. So that's why they're a bit nasty, and as I said, I wish there was a better way. Anyway, so other interesting thing about being able to package up patches using auto-wrapt like that is that you potentially could have this whole ecosystem of patches up on PyPy as well. If you've ever used New Relic, this is where I originally did the wrap stuff with. This is all this monkey patching happening to instrument modules for Django and Pyramid and Flask and all these. If I could package them up, you could have a core which does this concept of all this monitoring stuff, but then you have this whole ecosystem where people could actually just create packages for doing all this extra instrumentation for custom packages, and the people who did the core one wouldn't need to do it. So reason to use wrap, create better decorators. I've got that awesome synchronization decorator in there, but also a safer mechanism for monkey patching. Now, like with the decorator library where I do everything correctly to preserve things like introspection and make sure all that works, that all carries through into how the monkey patching is done, ensuring all that works. So that's why it's a safer mechanism for monkey patching. I deal with those things where if you assign directly, things don't always work. I worry about all of that. And that's it. So wrapped, you can find the docs on for wrapt.read the docs. And as I said before, I've got a whole series of blog posts on my site where you can go there and read intricate detail about why the existing way doesn't work, how to do it better, and also a bit about the monkey patching stuff as well. So, thank you. Any questions? Wait for the mic.
So sometimes when you use a decorator, it's not to return a wrapped function; it's to like add the function to a registry or something like that. In which case, you return the original function, and at that point, there's no extra cost of using the decorator. If you're using a wrap function, you've got the extra cost of an extra function call. I was wondering if you could talk about whether what kind of costs using wrapped to decorate functions introduces.
Okay. Yes. So first comment about that particular usage. Yes, you don't need wrapped when you're doing just that. So if all you're doing is taking existing function, registering it, and then returning original, you don't need wrapped. Okay, so make that clear. So to do all of this magic in wrapped, yes, there is overhead. And that is because that original simple decorator implementation, is not doing properly what's called that, it's not honouring the descriptor protocol. And there's all this stuff to do with magic binding and things like that. So to do that properly, your decorator itself has to be implemented as a descriptor so it can honour that protocol and pass it through to the original. So it does have overhead. And I have a blog post up on my site which goes through all of those overhead costs and gives comparisons to the basic way and also other libraries like the decorator package and my. Now in my particular one, because of the overhead cost, I have both a pure Python implementation, but also a C code implementation. So the C code implementation, because of the extra binding cost, is not going to be lower overhead as doing it the simple way, which doesn't always work. But it's still better than doing pure Python. So yes, I know there are issues, and you're better off just going to my blog site and look at the actual post about that. Any other questions? No more? One more?
Hi, good talk. Do you think the executable path files should be fixed or changed? Will they be changed? And do you feel bad for abusing that system?
Yes, I feel bad for abusing the system. And this is the... well, actually, no, I think I did write a blog post about auto-wrap, but yeah, I've been very hesitant in putting that package out there for people to use it. Would it be changed? No. And that is purely because there's too much stuff dependent upon it now. All of the setup, not setup tools, maybe it was easy install, was dependent on that feature. to do things properly, and I think maybe even pip still uses that now as well. So it's something that things are dependent upon, and I think it would just be too hard to change it now. Although I'm probably the only one abusing it by putting my own stuff in there, so maybe not. No? Other people? Good, I'm not the only one then. Okay, was that it? One more?
Right. Yeah, the synchronisation decorator seems really awesome, and I like the idea of it. It doesn't fit in wrapt. It almost seems quite different. Is there a reason it's not a separate module?
It could have been a separate module. I put it in there as more as an example. And yeah, so it's basically an example. I didn't want to... It was just a hassle to create another package, because then it's another thing I have to maintain. Yeah, so yes, it could have been separate. And certainly there are people who have packages full of a collection of different decorators. And I could have gone off down that track because, for example, LRU cache in the Python standard library, that exists. Well, it uses a simplified decorator, and I don't know if that has issues because of when it's being applied to, well, it probably won't work on a class method. If you put an LRU cache on a class method, it won't work. It'll break it. So I could have gone off there and created my own separate package with better implementation of LRU cache using Synchronise, but it seems like a better idea is to get wrapped inside of the standard library and then have LRU cache use my implementation.
I think we'll finish at that. Can we please give a round of applause again to everyone?
Thank you.